Hello guys, I am Mikhail Vashit Reddy, pursuing my BTech at Institute of Aeronautical Engineering. Today we are going to be discussing about an overview of 5G requirements and future accommodating scaling technology of future wireless networks. So before I dive into the topic, I'll introduce you to these future wireless networks first. The evolution of radio access networks have been marked by several key developments and technological advancements. Transition from 1G to 5G. Initially, 1G network primarily supported analog voice communication, while subsequent generations introduced digital technologies enabling data services along with voice. The introduction of 3G brought significant improvements, allowing mobile internet access and paving the way for applications such as mobile video and social networking. With 4G, the focus shifted high towards a high-speed data transfer and the ability to support streaming services, providing users with unprecedented mobile broadband experience. The move to 5G not only enhances data rates and capacity, but also introduces innovative use cases such as Internet of Things, augmented reality, and smart cities, addressing the growing demand for interconnected devices and low latency communication. So here we can see a small diagram depicting the growth of uh, wireless communication, where initially 1G wireless technology was introduced, where only voice was transmitted from sender to receiver, and it also marked the foundation for telephone communication. And slowly in 2G, the the transfer rate is drastically increased, and also it is and its network is available for a wide range of people. And in 3G, along with voice information, data services are also being transferred from sender to receiver. And 4G all talks about the data transfer speed incrementing, incrementing, which also paved way for many of the technological improvements like uh, streaming videos, online gaming platforms, etc. In 5G, 5G is new technology which is already been introduced, where from 2.4G gigahertz of data being transferred, it has become 5 gigahertz of data being transferred, which is more faster and paved way for many of the services like augmented reality and smart cities. So in this video, we are going to be discussing about 5G applications, key technology, design challenges, research and testing, and future predictions. So before we talk about these, let me introduce what is 5G. The architecture of 5G networks leverages a combination of existing technologies and new innovations such as um, millimeter waves, which allow for higher frequency bands and less congestion. 5G is designed to support a massive number of devices per square kilometer, enabling growth of IoT ecosystem where everyday objects can communicate and interact over internet. Ultra reliable low latency communication URLLC is a key feature of a 5G, making it ideal for applications requiring real-time responsiveness, such as autonomous vehicles and remote surgeries. Networking slicing, a crucial aspect of 5G technology, allows the creation of virtual networks tailored to specific applications for services, ensuring optimal performance and resource allocation. Enhanced mobile broadband enables the high definition content can be streamed seamlessly, which also enables services like virtual reality, 4K video streaming, and immersively gaming experience. 5G technology includes advanced security features like improved encryption and user authentication protocols, addressing concerns regarding user data protection in increasingly connected environments. So, as we can see, this is the rate of transfer rate of different things where water meters that is a channel of sending data from sender to receiver where message size can be maximum up to 100 bytes and message interval can be 12 hours and device density can be 10,000 kilometers square. Electricity meters the same, but the maximum of 100 bits can be sent, but message interval can be of 24 hours and the device density can also be 10,000 per kilometer square. Uh, Also gas meters. These can be also uh, the maximum message size can be 100 bits and message interval can be 30 minutes where device density can be 10,000 per kilometer square. Vending machines where typical message size can be 150 bits, 24 hours message interval and 150 per kilometer square. Bike fleet management, 150 bits of message, maximum message size. Message interval can be of 30 minutes and device density can be 200 per kilometer square. Pay as you drive can typical is having typical message size of 150 bytes and message interval can be 10 minutes with the device density of 2250 per kilometer square. Some of the 5G applications, especially in industrial automation, will benefit significantly from 5G, allowing for real-time monitoring and controlling of manufacturing process, enhancing efficiency, productivity, and reducing downtime. Smart cities while leverage 5G technology to facilitate interconnected services such as intelligent traffic management system, which optimizes traffic flow and reduces congestion using real-time data analytics. Healthcare applications will be informed with 5G, enabling remote patient monitoring and telemedicine, allowing healthcare providers to deliver care efficiently and effectively, regardless of the location. Augmented reality and virtual reality experiences will flourish with 5G, providing users with immersive environments for gaming, entertainment, and training purposes with reduced latency for seamless interaction. Vehicles will become more connected through 5G, enabling vehicles to everything V2X communication with enhancing safety features, traffic management, and autonomous driving capabilities. Future will see advancements through 5G applications, through smart farming technologies like IoT sensors, optimizing resource usage, etc. And here you can see mobile traffic by application category compound annual growth rate from 2017 to 2023. File sharing has become had increased it from 20%. Web browsing activities are increased from 21%. Software downloads are increased from 31%. Audio file downloads are increased from 32%. Social networking is increased from 34%. And now last with highest growth can be seen in video streaming with 48%. Massive MIMO multiple input, multiple output technology is crucial for 5G, utilizing a large number of antennas at the base station to improve spectral efficiency and network capacity without requiring additional frequency spectrum. Network function virtualization allows for decoupling of network functions from dedicated hardware, enabling the deployment of virtual network services on standard servers, which increases flexibility and scalability. Edge computing is integrated within 5G infrastructure to process data closer to user, reducing latency and minimizing bandwidth usage, thus improving the performance of applications that require real-time processing. The implementation of ultra reliable low latency communication technologies ensure that critical communications such as those in healthcare or industrial automation maintain high reliable and minimal data sorry delay. Advanced coding techniques such as low density parity checking, LDPC codes and polar codes are employed to enhance data transmission efficiently and improve error correction capabilities in high speed networks. Cloud based architectures are increasingly utilized in 5G, enabling resources pooling and efficient management of network services, which facilitate the on-demand allocation of a resource based on traffic needs. Here is the small image that depicts the 5G network embracing existing technologies and the targets of 5G technology, which include app coverage with data rates exceeding 10 gigabytes per second, network latency under 1 millisecond, capacity expansion by a factor of 1,000, energy efficiency gains by a factor of 1,000 per transported. The deployment of beamforming technology, which utilizes multiple antennas to direct signals more efficiently, requires sophisticated algorithms and precise synchronization to manage the increased complexity to antenna arrays. Integration of various network components and technology demands seamlessly cooperate between hardware and software systems, posing challenges in ensuring compatibility and performance across different vendors and standards. Achieving spatial sensitivity uh, necessity it's advanced techniques for distinguishing between signals from multiple users in dense environments, which can be complicated by inference and multipath propagation effect. The increased frequency spectrum utilized in 5G requires innovative design practices to mitigate issues such as signal attenuation and environmental obstacles, especially in meter wave communication. Thermal management becomes critical as Higher density of electronics lead to great heat generation, necessitating the development of efficient code solutions to maintain optimal performance and longevity of network equipment. Testing and validation of 5G systems require robust methodology that accommodate the diverse applications and use cases, ensuring reliability and performance in real world scenarios under variable conditions. Collaboration between telecommunication companies, technology firms, and academic institutions is essential for advancing 5G research, fostering innovation, and integrating diverse expertise in developing viable solutions. Testbeds serve as experimental platforms where researchers can simulate real-world conditions and evaluate the performance of new 5G technologies, allowing for assessment of different infrastructure configurations and network components. Some notable testbeds around the world include projects in urban environments that aim to explore the capability of 5G for smart city applications such as traffic management and connected services. Field trials are conducted to assess how 5G networks perform in terms of coverage, reliability, and user experience, often leading to valuable insight that inform future deployments and improvements in technology. Researchers' initiatives also focuses on optimizing algorithms for network management and resource allocation to enhance the efficiency of spectrum usage and minimizing latency across various applications. Regulatory body and standardization organizations are actively involved in testing process to ensure compliance and interoperability of 5G technologies across different markets and service providers. The development of 5G network is expected to accelerate significantly in urban areas, leading to increased competition among service providers as they strive to deliver high-speed, low-latency services to consumers and businesses. With the rollout of 5G, mobile broadband capabilities are anticipated to exceed 10 gigabytes per second, facilitating smoother streaming of high-definition content, enhancing virtual reality experiences, and supporting data intensiveness applications. Emerging technologies such as autonomous vehicles will rely heavily on capabilities of 5G with predictions that they will become more common as a infrastructure for vehicle to everything V2X communications matures. Smart homes and wearable technologies are also expected to thrive, utilizing 5G to enable seamless connectivity between devices, leading to automation and enhanced user experience in daily life. As 5G networks mature, we could see the proliferation of edge computing solutions, which will further reduce latency and improve performance for applications requiring instant processing and response times, such as gaming and remote surgery. Furthermore, advancements in technological or network slicing will also tailor services for benefiting industries ranging from healthcare to entertainment, creating niche markets within the broader 5G ecosystem. So let us wind up this topic. As 5G networks are developed globally, they will not enhance mobile communication but also significantly impact various sectors, including health sectors, transportation, and entertainment, promoting the development of new applications that leverage the enhanced capabilities and speed of 5G, ultimately leading to a smarter and more connected society. So here is the reference article which I have used in my presentation. For any more details, if you want to explore, you can refer these citations for more information. And World Radio Communication Conference can also be referred for knowing more about the history of the uh, wireless networks. So thank you all for listening to my lecture. Until then, take care. Goodbye.